Okay, in this video, we're going to learn how to solve function notation. Function notation is relatively easy once you kind of get the hang of it. But I know on first glance, you're like, what do I do with this possible equation or this function? Because it looks kind of crazy because it's something, when you first go into it, you're not used to saying, but once you understand what's happening here, it's just plugging in a number and solving for an answer. Plugging in an input, solving for an output. So function notation is when you end up having equations like this, like f to 4 equals, we'll say 2x minus 5. All right? So if you have something like that, you're like, what do I do with this? What's this 4 doing in here? All right. A lot of times when you see functions and you want to graph them, you'll see functions written as usually like y equals 2x minus 5. That could be a function. And then later on in your math life, your teachers will replace the y with an f of x to really indicate that it's a function. They can plug in several inputs or x values and solve for the output. Remember, f of x is the same thing as y. It's just a fancy way of writing a function. All right. And normally in class, if you're given this function, you would have to graph it. And this is a slope-intercept form. So we could graph this and say it's going to go through -5 on the y-axis, go up 2 over 1, and we can graph it. By the way, that graph is not this equation. That's something different we're going to do in a second. So what this means is if you notice, that 4 is right where the x belongs. So all it means when you see something like this is that it wants you to solve this equation. And wherever you see an x, plug a 4 in. Yes, that's all it means. It's as simple as that. So if I was to rewrite this and solve this, I would do 2. I would not put the x there. I'd put the 4 in parentheses, minus 5. Otherwise, it would be 24. And we're not doing 24 minus 5. So yeah, you just plug the 4 into wherever you see an x in your equation. So 2 times 4 is 8. Minus 5 is 3. And that's as simple as that. You just plug it in wherever you see it happening. We did another one. Say f of 2. We'll even step it up a notch and do a quadratic. Plus 1. All you do is you take your 2, plug it in where you see the x. Plug the 2 in, plus 1. 2 squared is 4. 4 plus 1 is 5. That's how you solve function notations if you're given actual equations. Or if you're given a specific input to plug in, especially if you're doing like piecewise functions, you got to find out where the domain is, and then you can choose which equation to plug it into. All right, that's how to do it with an equation. What happens if you're given a graph? If you're given a graph, all you got to do is find out where the x value is, go to the line on the graph, put a dot on that line, and then find out what the corresponding y value is. So here, we have a linear graph right here. It's f of 1. What does f of 1 equal? I'm sorry, f of -1. So I get a -1 on my x-axis. And then I am going to go down, all the way down to the line, which is right about here. So it's -1 down to the line. And then what does that touch? It cut 1, 2, 3, 4, 5, 6. It's -6. Looks like it matches up with about -6. If I lined them up right, like I said, I'm not using graph paper, so it's not exact, but it would go down we're going to call it -6. 1, 2, 3, 4, 5, 6. -6. All right. If I go, and then we're going to do the next one, f of 0. So that means 0 on the x-axis. Okay? Then I'm going to go down to the line. I already have a dot there. That's my y-intercept. And that's at -2. So it's -2. Now f of 2. So 2 on the x-axis. 1, 2. Go up to where my line would be. It should be right about here. That's about where 2 is. So what would that be on the corresponding y-axis? By going over, it'd be 1, 2, 3, 4, 5, 6, 7. So it would be 7. Put a little equal sign in there. All right, let's do one more. This is f of x would be 1/2. All right, so it looks like x of 1/2 would be right about here on the line. So if x is 1/2, what's the y value there on the y-axis? The corresponding y value will be 0. There you go. So we just learned how to solve function notation using an actual equation, and also how to get it from a graph. If I'm not good at the graph part, another option, I could have taken this line and written out. Written. Maybe that's why I teach math. I could have written out an actual equation and then just plug these numbers into the x value of that equation, and I would have gotten the same answer. So, all right. If you have any questions on math, apparently, ask me in class, or if I do post this on YouTube, ask me in the comment section below. See you soon.